For the video review, I want to start with why do we shade above when it's greater than or below when it's less than, just like we had in the last video. So for this one, once again, I have my 4 ordered pairs that I labeled here on the right, and I want to see if they make true or false statements when they're plugged into the equation. Remembering that first number is x, second number is y. This makes 3 greater than 3 times 3 is 9. 9 plus 4 is 13, which makes this a false statement. So that means this ordered pair should not be shaded. For the point below that, I plug it into the equation as well. 3 times 1 is 3. 3 plus 4 is 7. Negative 4 is not greater than 7, which makes this also false. Whoops, so I put that in the wrong spot. That one's false. That should be in a different color, though. So false right here. And then green, this one should be false. There we go. For the point negative 7 comma 0, I plug it into the equation. I get 0 is greater than 3 times negative 7 is negative 21 plus 4. This is negative 17. 0 is greater than that, which makes this point true, which means I do need to shade this point. And finally, we have 8 is greater than negative 9 plus 4. This is negative 5. 8 is greater than that, so this is also true, which makes this up here. Now, we can't do this for every possible ordered pair. It would take forever. So what we're doing is, instead of looking at every possible ordered pair, we're picking 1 or 2 and using them to test the theory. So when I look at a single point and I go above or below that point, it's going greater than that point or less than that point by just changing the y value, and then I'm shading just the place where it's true, and I'm not shading where it's false. Let's do a couple examples. This line is written in point slope form. If we remember, point slope form is y minus y1 equals parentheses m parentheses x minus x1. It's always tough to write and talk at the same time. So for this point, our ordered pair, now it's going to be opposite, so our x is going to be positive 2, and our y will be negative 7, and it's opposite because of these negative signs in here. And our slope is going to be the coefficient in front of the parentheses, which is negative 3, or negative 3 over 1. I can use that point and the slope to graph as many points as I can. So negative 3 over 1 means I can go back. Should look like this. Now, last video I didn't mess up the lines at all. Let's see if I can do it again. That one was not as good. So now we need to figure out if it's a dashed or a solid line. Because the equal sign is underneath, it should be a solid line. And it's greater than. So I'm going to pick a single point. I'm going to pick this point right here. And I want to go greater than that point. So I go straight up, which means I'm shading in this region up here. And some people have watched this video and said, well, this isn't so bad. Like, when does it get harder? And the good news is it really doesn't. It's just using skills that we've already mastered. So many times, this one will feel like one of the easiest sections we've done in a while. For this one, we need to graph it by either making a table or putting it in point slope form or slope intercept form. Now, I always like to solve for y because I think that's the fastest method we have. So I am going to solve this equation for y by subtracting 5x from both sides. So on this side, I have negative 5y. On this side, these can't be combined because you obviously know it. You might have even said it to yourself there. Negative 5x plus 5. Now I need to divide everything by negative 5. And here is probably the step that most of you will get wrong at least once. We divided by a negative sign, and we have an inequality, which means we need to flip the sign. And so I get y is less than positive 1x minus 1. From here, my m is positive 1, or 1 over 1. And my b value is negative 1, or the ordered pair 0, comma, negative 1. Then I can graph as many points as I possibly can. And from here, I try to make a line. Now, this one I got a little lazy, and the line didn't stretch all the way down, but that's all right. But I do need to make sure that my line is dashed and not solid, because we do not have the equal sign underneath our inequality. So we have a dashed line, and we are going to shade underneath because it's less than. So I pick a point. This time I'm going to pick right here, and I want to shade directly below that line, which is down there, which means I'm shading everything in this region down here. And that is solving or graphing two-variable linear inequalities. As always, if you have any questions, please let me know.